Hey class, we're going to continue and finish 8 point, where are we? 6, 8.6, yeah. This is page 3. Continuing with that, finding the roots of a complex number. So let's try a new one, square roots of 4i. Okay, so the first thing you want to do is write the value as in trigonometric form. Okay, so 4i, think about what that is in trig form. It's the positive imaginary axis. That's at 90 degrees. So the R is 4, cosine I sine 90. Okay. Now plug into that formula, this one that we've been using, right? Where we have n is, since it's square roots, n is 2, right? So square 2, which means we'll have 2 answers. And here we go. So we're going to have r to the power of 1 over n cis theta. Theta is at 90 degrees. And then it's always plus k 360 over n, which was 2. Okay. Simplifying this down, 4 to the power of 1/2, that's the square root of 4, which is 2. And then I'm going to break this up again, divide each side by 2. So 90 divided by 2, 45. And 360 divided by 2, 180. So k times 180. Okay. Now you always start with k equals 0. And you just keep on going until you have the number of answers you're supposed to have. So if I plug in 0, I get 2 cis 45. If you want to practice going to rectangular form, go for it. But these I'll just leave in the complex trig form. K equal 1. I get 2 cis. If I plug in 1, I'll have 45 plus 180. 225. And that's it. You might want to know, why don't we just do k equal 2? Well, if you plug in k equals 2, you'll be back to this one, right? Because k equals 2, it's 360 plus 45. You'll just get a coterminal angle to 45. So you'll get the same value. Graphing it, if I want to do my little imaginary real axes, I'm going to do a circle on this one. The R is 2, so it's a circle of radius 2. Right, so those are all 2's out to 2. And then just go to the angles that are specified, 45 degrees. There. There's 2 cis 45. And then 225 is the opposite direction. There's 2 cis 225. Okay. And there's the graph. Cool, cool. How about this one? Oof, 4th roots of that. Okay, so the first thing we got to do is get that in some trig form. I'm going to show you a little bit of a trickier, different way to, trickier, but I don't know, a different way to get into trig form where I don't have to use those formulas. I mean, I could do the R square root x squared plus y squared tangent, a over b over a, all that. Or I could notice that this one has some special values from the unit circle, right? So I'm going to write 8 as 16 over 2. And I'll show you why in a second. And then the other 8 as 16 over 2 as well. Right? And then factor out that 16. Let's multiply. And then notice what appears are those special values in the unit circle, halves and root 3s over 2. Right? I know that that's a point on the unit circle, -1/2 root 3 over 2. Where does that occur on your unit circle? If you look at your unit circle or think about it, that's at 120 degrees. So this is 16 cis 120. Cosine I sine, cosine plus I sine 120, right? Okay, so that's a little bit of a shortcut, quicker way to get it if you see it, all right? You don't have to do it that way, but thought I would show it to you. Okay, so that's the first step. You got to get the trig form. Next step, apply that formula. So then it's going to be fourth roots, n is 4. So we're going to have 16 to the power of 1 over 4. Cis, theta is my 120. And then plus always K360 all over n 4. 16 to the power of 1/4 is 2, right? It's 2 times 2 times 2 times 2, 16. And then I'm going to break this up. 120 divided by 4 is 30. 360 divided by 4, 90? 90. I should say that more confidently. 90. Okay, and there we go. Now, how many times I'm going to be plugging in k's? 4 of them, right? K equals 0. I get 2 cis 30. K equal 1. I'm going to get 2 cis 120. 2 times 90 is 180 plus 30, 210. And then do one more. 270 plus 30, 300. Okay. And then there's my answers. If you want to practice putting those in rectangular form, go for it. And then finally, I'm going to see if I can get a little graph here. Circle of radius 2, right? It's always the R. And then just draw those vectors at the specified angles. And you've got it. So 30, let's say that's about 30. 120, 210, 300. Okay, and then those are the 4 answers graphed. All right, again, notice it breaks up the circle in even parts. Okay, all separated by 90 degrees. Okay, last type of example is really kind of the same thing, but now you're solving an equation, right? Find all complex number solutions of x cubed plus 27i equals 0. So first thing is solve for that x cubed algebraically. So I just bring the 27i over. That's going to make it a negative 27i. Okay. And then write that in trig form. So what does negative 27i in trig form look like? Negative 27i is on the imaginary axis in the negative direction. So my r is positive 27. And my angle is 270 degrees. Okay. And then this is x cubed equals that. So then x is going to be the cube roots of that value. So now apply your formula of cube roots, right? So that same formula we've been using in the other problems. It's 27 to the power of 1 over 3 cis 270 plus K360 divided by that n, which is 3. Right? So really these problems are the same as what we've been doing, just presented in a little bit of a different way, solving an equation. Okay, so that's going to be 3 cis. Let's break it up. 270 divided by 3 is 90. 360 divided by 3 is 120. Now just plug in your k's. So if you plug in k equals 0, you're going to get 3 cis 90. If you plug in k equal 1, you're going to get 3 cis 210. And k equal 2. 240 plus 90, 330. Okay, and that's the trig form. Again, you can get the complex or rectangular form if you want. In the completed notes, check those out. I'll put the rectangular form as well, but I'll just, for the video, I'm just doing trigonometric form. Okay, that's it. We don't have to graph it or anything. We're just wanting to solve that one. One more. Ooh, x to the 5th. Wow, okay. That means I'm gonna have 5 answers. X to the 5th equals +1. What does 1 look like as trig form? That's interesting. Right? 1, positive real axis. 1 at the angle, then positive real at 0 degrees, right? So this is r is 1, angle 0. Apply your formula. So x is going to be 1 to the power of 1/5 cis 0 degrees plus k 360 divided by 5. Right? 5th roots n is 5. And that's that same formula we've been using. This is going to be the same as, okay, 1 to the 1/5 is just 1. Right? So I don't even have to write that. This is just cis 0 plus 360 divided by 5, 72. Right? Cis 0 plus 72, or just k 72. Okay, so k equals 0. We'll get x equals cis 0. 0 degrees. Right. K equal 1. Cis 0, by the way, is just 1, right? That is a complex number, but we're just going to leave it cis 0. K equals 1, we get cis 72. K equals 2. 2 times 72, 144. K equals 3. 3 times 72, 216. And then k equals 4. Last answer, k equals 4. 4 times 72, 288. Right, and those are my 1, 2, 3, 4, 5 answers. Okay, I got it. All right, we've got through that section 8.6. Send questions my way if you have any. Just spend some time with it, and hopefully it goes well. Okay, I'll talk to you later. Bye.